are fresh off of FIASCon 2025. We're thrilled that you joined us today. I'm Shannon Pendleton, and I lead Passive House projects at Sanderson Sustainable Design, and also projects at Source 2050. So get in touch. Let me know if you were at FIASCon. Say hi. And I'm going to hand it over to Carmel to introduce today's presentation.
Thanks, Shannon. So excited to introduce Matt Brill. He's a builder, innovator, and advocate for sustainable living. He founded Bauen Build to bring passive house homes to Boulder and the Colorado Front Range. With a background in business and a master's in urban design from UC Berkeley, Matt blends technical precision with a passion for advanced building science. He's committed to using high-performance methods to create durable, healthy homes that minimize environmental impact. Matt is an active board member of the Colorado Green Building Guild and lives with his family in Boulder in a certified passive house he and his team built himself. We also have Gabrielle O'Grady. She is a product consultant with 475 High Performance Building Supply, specializing in centralized H and ERV, energy recovery, systems from Brink. Her previous positions working in improving efficiency and optimizing building operations, 5 years in healthcare, and growing up around construction provide her a unique perspective on the relationship between our homes, indoor environment, and health. Gabrielle has an MS in Sustainable Architecture and Engineering, a BS in Physiology, Neurobiology, and Chemistry, and is a certified Passive House tradesperson and a lead green associate. We're so excited to hear about this project highlight, but first we're going to start with a video from the team. Take it away.
All right, we are currently at our 8th Street project. We're doing our first blower door test, and we are currently at 0.12 at 58 pascals. Super airtight, super proud of the build team for this one. Let's get it.
We are here in sunny Boulder, Colorado at a project that is being certified with PHI for a couple that has lived here for about 30 years, and they decided to upgrade and retire in a super comfortable, beautiful passive house. It's a relatively compact form house. However, there's always some intricacies in a home that has some architectural details. We have some graphics and illustrations that we share with architects and engineers that makes it easy for us to execute on the details of air barrier transitions. However, we want to focus on looking at some of those because that's the trickiest part of passive house, is getting complex transitions in the air barrier done in a way that's sequenced properly so that you don't have to go back and try to resurrect or fix something that wasn't air sealed properly to begin with. So what we're going to look at is a number of transitions and how do we make sure that we have that air barrier continuous, and how do we do it in a way that's easy for the team to execute. By sharing these details with all of you, we're hoping that both your architects, engineers, and your field teams are able to then execute and nail those passive house air sealing details. This is one of the areas that we need to air seal, and there's some sequencing. So what we do is we add these plywood squares with the edges spray painted pink and with an instruction on what needs to happen. And the reason we do that is you physically can't put something over the top of this without unscrewing it and in theory reading what's on it. And so that's our way of alerting people that something needs to happen in here in the future, and it could be weeks or months down the road. Hard to remember all those little things, so we just install these throughout the house, and then as it's executed, we take it off and then we save them for later use. So the other thing we love about Intello, especially the Intello X, because it's white, is it's basically a blank canvas for us to write notes. So you can see here, this is the window number, the position number, so that the window installer knows that they're putting the right window in the right location.
One of the biggest things on a construction site is communication. We do this in a couple different ways, verbally, through infographics, and then those pink signs you just saw. Not every sub that is on our job site is totally familiar with passive house. You know, this is still a new style of building. So having these infographics helps with just training future subcontractors about passive house details and ensuring materials are treated properly. This represents the allowable hole sizes in different lumber types, and we've pulled this from the Rosenberg manual, but only specifically for lumber types on this job site. So it's very quick to reference for subs, so there's no question about it. It helps with quality assurance versus just quality control. We're enabling our subs to be very thoughtful. There's no question about what they need to do, it's all right here. And then there's even a QR code to reference the exact manual if you need more details. We find that it's worth putting the time and effort into this signage just for the amount of rework that it saves. Rework is a killer on a job site. It's money, it's time, it's effort, and this stuff ensures that we minimize rework. So the owner of this house is an artist, and she requested to display a piece of her art at the front entryway. So we built this niche, but this niche goes past the depth of the service cavity. So we needed to use this box as an air sealing layer, which we taped into the Intello layer. In building passive house, you're going to run into instances where your air barrier cannot be continuous. There needs to be a bump out for different installations. So this same concept that we built for this niche applies to other areas in the house and how you would use this box as the air sealing layer to maintain continuity.
So what we're looking at here might not look very pretty, but behind all this protection is a lift and slide door. And obviously the gaskets and all the components of this very expensive product that's keeping this home air sealed and insulated is important. So what we've done here is we've basically just built a temporary construction entrance. It's floating over the sill of the frame of the door, and here you can see the remnants of the door is this handle, which is also protected from the manufacturer. So we've just protected everything else. So it looks good when the homeowners move in, and we make sure that all the gaskets and seals and rollers on this door operate smoothly for years to come. This is one of the areas we wanted to highlight. A lot of it's hidden right now, but this is a really key area of air barrier transition and also insulation detailing. So we have a double stud wall here with a service cavity. And so the air barrier is transitioning from the subfloor to this Intello membrane that you're seeing here, and then up and under on the underside of this small roof deck. So the key things that are really important here are you can see these LVL. They're multi-ply LVLs. I think they're 5 plies because of the structural requirements. But what's really important here is that we have a continuous framing member that we can air seal, and you can see the outline of the blue tape is such that that's relatively easy to do when designed properly. But imagine if that beam here went all the way through past our air barrier, it'd be a lot more challenging to execute on that. So we worked with the engineer and the architect to make sure this is planned properly. And then during framing, what you can see here is we air sealed the top plate of the outer wall, and then that allows us to transition through the double stud cavity from the vertical wall surface to the horizontal underside of this ceiling. So this area that we're standing underneath is probably one of the trickier areas of the house. So you can see the plywood has taped Tescon Vanna seams, so that's actually our air barrier. We had a lot of density and weight of insulation, so we worked with the consultant to specify plywood there instead of Intello. But the tricky part is that we have this little bump out here, which is actually a laundry chute that the owners requested, and also a little bench seat that is by a window. So the air barrier is transitioning from this flat roof that's above us up vertically to this window seat and laundry chute, and then is transitioning in both directions as well. So there's a lot of complex corners and angles that can be very tricky to visualize. So that's why we're trying to show you some of these details in person so you can see how things had to be taped in sequence. The one thing that you'll notice is that you'll see some material on the top plate here. This is actually not necessary, and it's not the air barrier. You can even see we try to alert people of that. So we have some notes there to just indicate, hey, you don't actually need to tape that connection because it's not important. So both are we alerting people what needs to be air sealed in the future and what doesn't need to be. So you're not questioning whether you've forgotten something. But the reason why it's taped is we thought it was a lot easier for framers to just say tape every top plate of every wall so that you don't have any ambiguity about missing something or not. And the cost and labor to tape 10 feet of top plate is not worth the hassle of forgetting it if you're trying to be picky about where it goes and where it doesn't go. But we're actually using Hero to wrap the top plates. Part of it is because we have a 2x6 wall. It needs to go up and over both sides. Doing a piece of tape for that is more expensive. You typically would have to use 2 pieces to get it to fit. And the Hero is much more durable. So as the framers are laying joists on it, it has a lot more durability of that outer surface to make sure that it doesn't get damaged during installation. Then you can see the red spray paint on that hole there. Because that is going through the air barrier, that does need to be taped. So we're alerting both our own teams and others about what needs to happen in the future, because we're waiting for a penetration there by one of the mechanical trades, and then once they're done, we'll tape that and air seal that hole. One other even trickier detail, we're in a kitchen area, and so you can see we have a exhaust hood. So the homeowners chose to have a kitchen exhaust at a lower CFM, and so that was another transition that we needed to accommodate for. And we're really particular about avoiding roof penetrations that, if at all possible. And this is just an example of coordinating with the architect, because this wasn't originally planned like this, so that we can have that duct come out, transition horizontally, and that way we can much easier waterproof that versus having to deal with something coming up vertically in this flat roof. So here what we're looking at is a beautiful wide entersign window with a patio door built into it, allowing access to this rooftop garden. So you can see here we have a pretty tight transition. We had some height restrictions on this particular lot. So you can see again, we have a gabled cathedral ceiling here, and the air barrier is the plywood with our taped Vanna seams transitioning into this rough opening where we have a window or door buck around the entire side so that we can get a very easy, clean, continuous air barrier. Another example of a transition, by using a box around this transition like we saw earlier, it allows for taping right to that box. You know it's airtight, and it makes for these types of transitions really easy. All of our windows that we're installing are being center mounted in the frame for the best possible energy efficiency. And we're using double-sided tape to allow for a zero reveal installation, which is pretty common in high performance windows. So you have this beautiful pine here that we obviously don't want to cover up. So we first apply the double-sided tape to the inside of the frame. And you can see here it's very secure, probably putting 50 pounds of force on that. And then once the window is installed and screwed in and insulated in this gap here, we'll take off the back side of the backing of the double-sided tape and then adhere that up onto the air barrier of the rough opening. We do this on all of our projects. It's really easy. Our window installer is used to it. We think it saves time and saves cost. It's just a really clean detail. It allows for really nice architectural details and obviously super airtight installation. Thank you so much for joining us here in Boulder, Colorado. We really love showing you the details on this particular house. While the details may not be the same on your particular project, the principles are the same. You want to have a really well-designed project with your architect and engineer, and that allows you and all the trades that you're partnering with to execute on those details.
And here at Bauen Build, we really pride ourselves with nailing those details. The stuff behind the walls that you don't end up seeing is just as important as the finishes. And we geek out on these details and getting them right. I think everybody at the end of the project really appreciates the attention to detail. We're building a really comfortable, durable space for the owner, and nailing those details is of the utmost importance to ensuring that.
Great. Thank you so much for having us today. Gabrielle and I are super excited to talk with all of you. We're going to dive into some of the details about that particular project and kind of extrapolate a little bit more with photos that we had during the construction to talk through exactly what was happening kind of behind the walls. It was a little bit hard to see in the video. We're going to connect the importance of air sealing and ventilation as well. And I think that's another key aspect of long-term, durable, healthy homes, is not just focusing on the air sealing, which is definitely a hot topic, but also focusing on how the home's going to operate and breathe once you're done and once the clients are living in the house. And so this, just to kind of ground everyone in why we stress airtightness so much, is this is a graphic that we actually got from a consultant we work with, John Lozier, and we really like how he presents the information to the benefits of passive house and high performance house to his clients and to our clients, and really the levers that you have to pull to increase the performance of that house. And you can see here, both air tightness and windows are the two biggest levers that have a major impact on the amount of energy usage that a house has. And one of the things that we really value with making a super airtight house is it allows you to then control the environment in which you're in. So instead of just having a house, maybe it was built 20 years ago that was super leaky, whatever outdoor pollutants are in the air at that given time is going to be transmitted into your house. So by creating that really airtight envelope, you're then able to then build into the project systems that allow you to create what is arguably going to be the most comfortable, quiet, and durable structure that you'll ever live in. And I think as we were talking on the beginning part of the project is just making sure that that structure is going to last for generations to come, and just thinking about the full cost of ownership. And while some of these investments might add to the project cost at the onset, can actually help to reduce the overall cost of living in that home, and obviously make it a much more comfortable and pleasant place to live. So before we dive into some of the specifics of the case study, just want to highlight the three things that we're going to focus on today. So first is the connection between thoughtful planning in the design phase and how that contributes to easier execution in the field. And that was touched on quite a bit in the video. The second is how to communicate to your teams during that phase of framing and air sealing, and how you can make that easier, faster, and ultimately get better scores on the blower door test that's required for most homes and definitely required for a passive house. And then lastly, just focusing on some of the factors to consider when designing the various components of a ventilation system, and making sure that you're able to control all the different aspects of the air that's being transmitted into your house. So as we highlighted in the video, this is a really unique couple. They've lived on this property for 30 years in a 600 square foot house that had some minor updates in its lifespan, but not much. And so they lived fully in that house. They considered moving elsewhere within the city of Boulder, but ultimately decided that they really loved their neighborhood and their neighbors, and so they decided to rebuild. The owner, one of them is an artist. It's really important for her to have a space for her to do that art. The studio itself is not going to be certified passive, but we're designing it in a way that it is going to be very airtight. She has the same windows that they have in their home. And we integrated a whole house ERV system into that space. He is a climate scientist. And so I think that's a common thing we're seeing with a lot of our clients is they have maybe a little bit more knowledge than an average person on just the impacts of buildings on climate, and both how you live in those spaces. Originally, passive house was not a goal of theirs, but very airtight was. We've since decided as a team to certify the house, but that wasn't an initial requirement for the project. As you saw in the video, it's a super tight lot, which did make for challenging construction. It's about 2,800 square feet, and then added to that is that detached studio that you can kind of see on the right side of that aerial photo. So what we want to dive in today is just some of the more trickier situations that we encountered, and how we tackled those both in the design phase and in the execution phase. So we'll look at quite a few photos of the project, and then I'll transition to Gabby for some more details on ERV and HRV that they provide through Brink, and then we'll open it up to questions. So the first detail we wanted to dive into is what we call a reverse overhang. And you can see in the diagram on the left, a reverse overhang is essentially where you have living space below a roof deck that transitions to a second floor with living space that's inset from the lower level structural wall. And you can see this rendering on the right depicts where that is on this particular house. And this is the area from the video that we saw and focused on quite a bit. We have another one on the north side, where they have another rooftop garden, but we'll focus on the south one because it's a little smaller, easier to kind of comprehend when looking at photos. So this photo depicts exactly what you can see in that diagram on the left. And we worked with the engineer and architect to have solid framing members. You can see both kind of on the far side of the photo, and then kind of coming forward on the right where the arrow is pointing. Those are both beams that you can see they're taped with Adhero, so they're blue. And so what designing it this way allows us to add that air sealing layer before adding the joists on the rooftop garden section of the house. So the kind of the exterior envelope section. And it just makes it much easier to do, because if you can imagine, another way that this could have been designed by the engineers is just to have those eye joists that are on the right side of the photo continue all the way through to the exterior wall. Like in theory, that could have been fine for the structure. And we've seen designs that have situations like that. So then just going up, now we're looking basically down at that same photo. You can see how we've been able to transition that air barrier from that beam up onto the subfloor. And then once we get onto that subfloor, our subfloor can be an airtight part of the house. We're then able to, going to the next photo, see how we've been able to transition that to that interior air barrier. Now we're looking kind of out towards the area of the rooftop garden, and we were able to transition via that structural beam onto the subfloor and then up into the interior air barrier on the second floor of the house. So this is a common architectural design move just for architectural interest, potentially building codes. And so kind of scaling the house back as it goes up is generally common. And what we really try to stress with the partners that we work with is that, hey, let's work together to design this in a way that allows us to execute much easier. The other one that we touched on in the video is how we use both the top plate of a first floor wall that's transitioning to a second story. And so you can see here on the right, we basically cover the top plates of all of our walls with Adhero. And then for the transition to the second floor, you can see on the photo at the right, we're using the rim joist to then transition that air barrier up and over onto that second floor. So you can see the Vanna tape, which has all the little white lettering on it, is actually connected to the top plate on the bottom of that LVL, and then similarly connected to the subfloor. And so that allows you to then transition that air barrier pretty easily between floors. One thing that isn't always common structurally, again, depends upon your location, is in the parallel condition to those floor joists, sometimes a rim joist isn't required structurally, but we will ask for that, even if it's just a cheaper material, an LSL or even plywood, again, allows us to then transition that in a condition that is a little bit trickier to do if you don't have some solid surface to tape to. So transitioning more onto the communication side, I mean, as you saw in the video, it's kind of over communication is really key, and just being thoughtful and planning ahead for all the different project team members that will be experiencing the site and have to, respect the air barrier and potentially penetrate the air barrier. So one thing that we do on every project is we do a small mock-up of the wall assembly where we're using, actual dimensions, the same materials that you'll see once the house is actually constructed. And we use that mock-up to talk through with our trade partners, what it is about this house that makes it unique. The added benefit to the mock-up, especially if you have some unique exterior cladding or how transitions are happening at windows, it allows you to then also build out some of the architectural aspects to making sure that the sequencing on that aspect of the project is also easy to execute. And you've got the details you need from your architect. The last one is that we do an intro meeting with every trade partner that comes on site. We kind of look them in the eye and say, like, this is why these things are important. And we don't just assume that they're going to read the posters. We take them over to there, that they have that resource available to them. And then the other thing that is really important to us as a company is on-site supervision. And so to the extent that the project has the capability to support that, that is also a really critical component. Because the reality is there will be questions, and having somebody on site that has the answers just makes the project go smoother and ultimately leads to a better outcome from a performance perspective. So shifting now to the last topic we wanted to focus on related to ventilation. The reality is that with an airtight home, you do need proper planning for ventilation. With a passive house, this is definitely a requirement, but building codes have definitely strengthened in terms of their airtightness requirements, but haven't necessarily strengthened with as much vigor, in my perspective, with thinking through and planning for ventilation. And the way I think about it is airtightness without ventilation is kind of like holding your breath. You definitely need to be able to breathe, and you want to be able to control how that breathing happens. So the three goals for this particular project related to ventilation, obviously fresh air supply, that was a requirement, an absolute must. It's all projects we do have a whole house ventilation system, regardless of whether they're certifying as a passive house. Humidity control is another one that was really important to us, and then airflow. So we're going to talk through each of these briefly. So obviously, knowing the details of what is required for your particular climate is really important as it relates to picking the type of system. The other really important aspect that people like Gabrielle can help with, or potentially your consultants, is properly sizing the system. And then the key thing that we focus on in the design phase as it relates to an ERV is proper planning for the intake and exhaust. These are oftentimes considered, but in my opinion, not considered fully enough. And thinking through the architectural impacts of having a penetration on a certain aspect of the home. So we now generally really encourage 3D modeling of how those ducts will be routed from the mechanical room out into the exterior environment. So that makes sure that we're not having any structural conflicts, and then architecturally, we're fully considering the impacts of those vents on the outside of the house. And then the other just tip that we've identified over doing a number of these projects is considering 2 smaller units for larger homes. Generally, most homes that are being built, you can get away with 1 unit, but we find that by using 2 smaller units, the systems can operate slightly more efficiently. You can minimize the duct runs, and ultimately could lead to better performance of the system. So what we wanted to highlight on this particular project is some of the ways that we get the ERV ducts routed through the house. We only use the rigid ducts just because they have a little bit better ability to prevent kinking or any restrictions to the airflow. So you can see these are those white vertical tubes in these photos. So we generally require a full 2x4 service cavity, and that allows us to then add these ERV ducts in exterior walls. And you can see that, we're also packing in a lot of other things into these walls. And so you can quickly see the value of having that full service cavity. The photo on the left, we have speakers, brackets for a floating shelf, plumbing stacks. So a lot of things can definitely fit in there. And then your inboard of your air barrier, you're not penetrating it unless you're going outside with a hose bib or something like that. So that really adds a ton of value and allows us to get those ERV ducts routed into a place that with a modern home may be difficult to achieve if you've got a really open floor plan. The one on the photo on the right is just showing how we're also able to then go up through that same wall and then go up into the floor system. So potentially doing a ceiling mounted extraction vent for like in a kitchen area or a bathroom area. So that allows you to kind of get up into that space as well. And then the photo that we just looked at, now you can see how we've transitioned some of those air ducts, ERV air ducts, into the second floor through that same service cavity. And this particular one, this is an ideal location because it's right near the nightstand of this homeowner's bed. So 24/7, especially as they're sleeping, they're going to get fresh air supply. The second ventilation component that we wanted to highlight, and it was a particularly important goal on this project, was humidity control. So with airtight homes, managing humidity is really critical. We're using smart vapor retarders to also help with that regard. But one of the things that I think is often overlooked is even Colorado, it's considered a very dry climate. When you actually look at the data, it's actually relatively humid. So the average relative humidity in Boulder is 51% throughout the year. And so it's generally lower in the winter and a little bit higher in the summer. And so what we've found is that, with 60 to 80% humidity in the summertime in Colorado with an ERV, that is dumping in humidity levels that are probably too high for what you really want in that structure. The ERV is great for the winter because it preserves that humidity when you want it. And so that's why with this particular project, we added both dehumidification and humidification systems. And the reason we recommended that to the client and why we're recommending that for all of our projects is similar to the ERV and wanting to control your indoor air quality. With a humidification and dehumidification system, you're able to do the same thing at the humidity level. And so ideally we can maintain, depending on the client's preference, around 40% throughout the year, 45%. And you're able to then regulate that and control it on your terms with those two systems. And those particular systems are relatively inexpensive, easy to incorporate into the overall design. And we think, why not, be in control of those numbers? And ultimately, the comfort and durability of the house will be much better as well by having those things under your control versus letting the environment outside you dictate what your indoor humidities are. The last one that was really important to this particular client, and I think could be overlooked by some project teams, is just the importance of airflow and feeling that airflow. These clients really like ceiling fans, and they like just the feeling of that airflow on them while they're sleeping. And I think it's important, especially if you haven't worked on a project with an ERV, is that while that's providing the quality air that you need, it is definitely low volume. So it's not gonna you're not gonna feel it. And so that's why we incorporated ceiling fans into the bedrooms for this particular client's goal. So just thinking through, it's a minor aspect, but I think it's something important. Again, does not have to be costly, but if you're planning for it, you have the ability to kind of control how that aspect of the home feels for the client once they move in. So with that, I'm going to transition to Gabrielle, who's going to talk through some aspects of the Brink ERV and how the quality of the ERV system is also really important to consider when planning the type of system you want to install.
Great. Thank you, Matt. So I am the team manager for the Brink Flare ERV and HRV systems that we supply here at 475 High Performance Building Supply. As you can see, the system here, it is currently available in 4 different sizes. And on our website, you can research more specs there. Matt, you can click the next slide. I kept my slides short because I am very excited to get questions from the audience. So I'll be brief here to allow time for questions. But essentially, Matt's team had worked with us with actually a different project in Louisville. I was working intimately with them to create the design for that project and full takeoff. I really enjoyed working with the Bauen Build team. They were just as attentive to the ERV install as they were to the air sealing details. They reached out before and throughout the project. I would highly recommend reaching out through the design phase, just as they got creative, for instance, for that wall intake. We are happy to make suggestions or just give you things to think about early on in the project. And one of the things I really liked about working with Bauen Build is they were very excited to learn about a new high performance system, and they approached it with a healthy amount of questions. We were able to get them actually out to a different local project site so that they could gain confidence in the system. I think that they found that it had the same high performance that they expected out of these units, and then the same home run system that they were used to as well. So we love seeing, GCs and that do their due diligence. So here you can see just a few of the features that set the Flare apart and make it high performance. I do have in the appendix further details on these, but to save time, just this one slide here. Matt, you can click the next slide. So for the project in Louisville, we did the full design for that project, balanced ventilation. So exactly as much supply as exhaust, and the bathroom exhaust met code requirements. So you can eliminate exhaust only bathroom fans. Again, we're happy to work with you throughout whatever phase of the project you're working on. Early, we always love, because then we can make recommendations to keep those insulated ducts short, as Matt talked about earlier. And next slide here. And lastly, we provide a full kitted system, which reduces installer errors. So it's that 3-inch ducting that Matt showed that fits nicely in a 2x4 cavity, along with insulated ducting. So you can see some of those details here. Again, those 3-inch ducting inboard of Intello, and then Roflex gaskets sealing to the exterior there to create air sealing around your ERV install. So that's, I think, all I have. And
Yeah, thanks, Gabrielle. Just lastly, want to just highlight some of the graphics that we were showing today are available on our website to download. Just go to the URL you can see here, or scan the QR code. So this is our first version of that document, but the goal here is to share with the community some of the learnings we've had from some of the aspects we discussed today, and we're going to continue to add to this document. So we're trying to provide a visual 3D aspect of what these trickier transition details are, because oftentimes you're getting them in 2D on a plan and it can be hard to comprehend. So feel free to download that, give us feedback if there's other things you'd like to see as well. We're happy to expand it over time.
Matt, what a perfect way to end the presentation, on the note of opening sources and sharing resources. There were so many questions about who did those diagrams. So now we know those are our Bauen Build diagrams, and they're available for download in those resources. That is such an asset to the community. Thank you for sharing this wonderful project, sharing your lessons learned, how to overcome and execute air barrier transitions, avoiding install conflicts with those 3D renderings, considering multiple zones for ventilation, and ceiling fans for comfort. We tend to forget that simple addition. We got a lot of great questions besides the diagrams, but first we're going to take a quick break, and Shannon is going to share some upcoming events in the Accelerator community.
Perfect. Thanks, Carmel and Matt, Gabrielle. What a fantastic presentation. I definitely scanned that code. I'm going to check out that manual. I know it is a difficult task to put something like that together. So kudos to your team. And I especially loved how much you worked in tandem with the client and with your suppliers to make sure that everybody understood how all the systems, all the envelope details were going to work together. So we do have some events to share. Our recent podcast episode discusses the efforts in providing affordable and sustainable housing in the UK. The link is in the chat, so you can listen to that. And live event next week will be Field Notes. And that's our Summer Lab Report Part 2. So this is a special session featuring reports from the Reimagine Building Summer Labs. We'll dive into some of the biggest questions facing high-performance building today, directly from practitioners who have spent the season debating, testing, and learning together. So they share practice-based insights that you can apply to your own work. And this session is going to focus on retrofit and fire-resilient design. Our component spotlight next Thursday on 10/23 with Cascadia. They're going to show you window strategies for a wildland urban interface, or WUI design, WUI. If you're not familiar with that, get familiar with that. There is a link in the chat to register for that. And for our community events, we've got a building science symposium on 11/5, International Passive House Open Days on 11/7 through 11/9, and Reimagine Building's Best of Retrofits on 12/5. So finally, a quick overview of our Reimagine Building Collective events. We have the Honeybee Office Hour Tour on 10/16, the AMA Friday with Kimberly Llewellyn. I am so excited for that. Lots of HVAC info coming this Friday. And Reimagine Design with Yal Santopinto. I hope I'm saying your name right, Yal, on 10/21. Thank you so much. And Zach, over to you for a quick thank you to our sponsors.
Hey, Zach, you're on mute. I'm having a day. Sorry about that. So I want to thank the fine groups that are making our work here at Passive House Accelerator possible. So a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. Thanks to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Facro, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Technologies, and Source 2050. And thank you to our patron sponsors, Building Type, Brennan, Holstrom System, Inotech Windows and Doors, Lamelux, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
Thank you, sponsors, and thank you, Zach. First up for questions, we have Joan Connolly. Are you on, and would you like to ask your question?
Oh, hi everyone. It's a pleasure to be here. Yes, and so my question is this, is I noticed a large window with the two panes of glass forming the corner detail with only the frame. And I was wondering, could you review how this corner detail meets Passive House criteria?
Yeah, so the window is Passive House certified, and there's a couple of different ways that EnerSign does that. In this particular example, the frame, the outer edge of the frame is insulated, and they get connected structurally. And then the trim that you saw both on the outside and the inside is actually added after the fact. So the aluminum cladding on the outside is added in the field after it's mulled. So there's a thermal break resin material underneath the aluminum that allows it to be thermally broken.
Oh, so you mean in the vertical frame?
In the vertical paint, vertical dimension, correct.
Mhm. Okay. Oh, great. And so does the supplier, like if I went to the supplier website, I would be able to find examples of where a window can come at a corner like that?
Yeah, I'm guessing they I don't know if they have the CAD files on their website, but definitely if you reach out to EnerSign, they would definitely have the CAD files available to kind of see how that's depicted.
That is amazing because my first influencer was Frank Lloyd Wright with the corner window.
Sure. Yeah.
And as a young girl, I just fell in love with that. Yeah. So I'm
It's
so
a beautiful
happy.
detail. Yeah,
It is. And so I'm so excited to see that it's in Passive House.
for sure.
Thank you.
Yeah.
Thanks, Joan. And George, you had a question about the double stud assembly in the air barrier location.
Yeah, hey, can you hear me okay?
Yeah.
Okay, good. No camera today, sorry. Yeah, so double stud wall is already 2 rows of studs, and then you guys did a third row with a furring cavity and put the air barrier
Yep.
on the inside,
Yep.
and then you had to jog in and out at the second floor rim joist, and so I'm just wondering why inside instead of outside?
Yeah, why the air barrier in the inside?
Yeah,
So yeah, this is a project that we did with EMU Systems, and they have two standard wall assemblies that they've modeled. And so that's why it's there. That's what the model of this particular assembly was done. But ideally the air barrier is generally in the center part of the wall cavity from a thermodynamics and humidity and vapor control perspective. Um, to your leading part of your question with the three walls, our general preference as a team is to do a structural wall, an interior surface cavity like you saw, but then do exterior insulation. So that's our preferred because I think it's less framing lumber and less framing time. And I think the difference in performance is not significant. So we do generally prefer that assembly, but that's why we had this particular assembly and why the air barrier is in the center of the wall. We do have a secondary, the Adhero that you saw, the blue Adhero is a secondary air barrier and our primary weather barrier. So just to explain kind of the other aspects of this particular assembly.
And Matt, when you say it was modeled by Emu, did they also do hydrothermal on those?
Yeah, so they have all that done, and that's why the premise of working with them is that we don't have to do that custom for every single project or every nuance to a wall assembly. And we really love that kind of plug and play mentality, and trying to democratize more of these projects and getting the cost down, I think is a big win, because even the consulting fees to model it could be prohibitive for some clients. So we like that aspect of working with them. And then now we're familiar because we've done both of their wall assemblies numerous times. We don't even really have to look at the drawings. It's just in our head of what we need to do.
Yep. Systemize everything.
Yeah.
We have DBask coming up next. I see you came on camera.
Hi, how are you? Thank you. Really, really cool build. Thanks for sharing your details and the way you're doing it. So just to touch back on that service cavity seems like it makes it simpler and and more cost effective than just trying to do the Intello on the final wall right before the drywall and trying to get all the boxes and electrical and everything else.
Yes.
Okay, that makes sense. Can you speak a little bit to how you handled your the hood, exhaust hood for the stove? We
Yep.
always struggle with that because makeup air, you
Yep.
can't seem to get those in the ERVs. How do you get damper it? So we just kind of
Yep.
don't put them. So I wonder, how do you handle those?
Yeah, no, it's a good question. And back to your first question, we have a blog post on our website about a retrofit we did where we had to air seal from the inside and went through the pain of air sealing around electrical boxes. So check that out if you're interested. It's definitely doable. And for retrofit situations, it's a fantastic way to do it, because the reality is we can't build all homes new. And so we're gonna have to retrofit some of them and make them better. To your question about kitchen exhaust, yeah, so the code requires that I think it's 300 CFMs, less than 300 CFMs. You don't require makeup air. But the reality is, with an airtight house, I don't think the same premises in making that code requirement apply. And there's a really great YouTube video that Jake Bruton did, kind of demonstrating that especially if you're going above that, 600, 800 CFMs, you're basically running a blower door test in your house. And so what we have 2 projects in design right now, and what we are doing is because they do a lot of cooking. And so the reality is that vent is going to be on more than maybe somebody that's just cooking eggs in the morning once a week. And so we are incorporating makeup air with a damper and preheating for winter conditions when the air is cooler. And we were able to model that at least through the FIAS program and did not cause problems to the overall model. And we like that because it kind of removes any human error in having a hood that maybe is the CFMs are just too high for the tightness of the home. So that's kind of our new model going forward, for at least for clients that are cooking a lot. If they're not cooking a lot, we really encourage them to, whether they really need the hood or whether they need it vented. There's charcoal hoods that are available, and then you can also up the number of exhaust vents in the kitchen area through your ERV or HRV. So I think it's a combination of designing the systems appropriately, but then also understanding what the goals are for your clients and how they live and operate in their house.
Is it an off-the-shelf system? Can you?
Yeah,
mention what it is?
I'm blanking on the name, but yes, it is off the shelf. I think it's by Fantech, if my memory is right. And they have it's filtration, MERV 13 plus preheat plus a damper. We haven't tested the damper in a blower door setting, but
Nice question.
Yeah. So, but it's probably better than putting your house under 50 pascals of pressure, once a day.
Sounds good. Thank you.
Yeah, for sure.
Great questions. Yes. And even better answers. Up next, we have Tom Gallagher. Tom, are you free to unmute and ask your question?
Sure, thanks. I think several others had asked the same of one of mine of who did the 3D modeling of the ERV ductwork. So maybe I'll let others to ask that one. I think one of my other ones was especially like in Boulder County, where there's kind of a context imposed square foot limit. You're kind of battling a client's need for a room that's this size.
Yeah.
How do you navigate that? Maybe it's a little different in the city of Boulder, but in the county, I know we're kind of up against that sometimes. So introducing yet a third layer to that wall becomes a little bit of an uphill battle.
Yeah, it's a great one. City of Boulder is similar. Two things, I think from a advocacy perspective, working with your jurisdiction to consider the sheathing as as the metric by which you're calculating FAR is a really great one. And I think it encourages exterior insulation and encourages clients to do a high performance structure because it doesn't count towards their FAR. So that's one thing that as on the Colorado Green Building Guild, we're working on with the city of Boulder. So that's something that, if you can work on that, that negates that as an issue. And I think it is a win-win in terms of the climate and the clients. To your specific question, a lot of times the architects are having that discussion with clients. And I think, and I know Greg Fisher's on the call, and maybe he can remember, I think for the house that we built with my team for myself, I think it was around 300 or 400 square feet of wall cavity that, it counted towards FAR, but did not deliver us volume to live and play in. So it's a real thing. And how you navigate it is difficult. I think just demonstrating the value of the structure and the long-term durability of building this way, I think, I feel like I'm okay giving up 200 square feet of space for that benefit. And just the comfort that I'll have living in that environment. And I think a lot of people are aware of this, but with better windows and a better wall assembly, you can use every square inch of that square footage. Whereas if you're not building to this higher standard, might have cold or condensation on, areas in your windows. And then you're actually shrinking that space maybe even further than you would with just a 2x4 wall. So you could maybe try to argue that, especially if they're considering triple pane, high quality window versus just a general, double pane window that most projects would select. So that's maybe one angle you could tackle. On the modeling, since you asked it, generally most of the architects we work with build in 3D. And so we've just asked the architects to do that modeling. And initially it was a little bit of a hesitation on the two architects we've been working with recently on it. But the reality is it didn't take them that long to do. And they actually were so impressed at the value that delivered for the overall project and the outcomes that it will deliver, that they're now doing that just regularly on other projects because it didn't take that many hours of time.
Cool. Thanks.
For sure.
Great. Thank you, Tom. And up next, we have Rick Mingo. Rick, would you like to unmute?
Sure thing. Thanks, Matt. Again, as we talked about the breakout room, so many things in this presentation that's going to apply to our build. One question, Boulder, you're a couple thousand feet lower than we are on the north end of the Springs. So we're probably a bump up in the climate zone. What did you end up doing for the insulation inside that double wall? And what would you do if you had done that as a exterior insulation and R values?
Yeah, so in terms of the R values for your particular climate zone, I would definitely, making sure you're building a team that can help give you the specifics there. But yeah, especially if you're doing exterior installation, you can just continue to increase the number of inches to get the target you're after or the target that's required. I think that one thing to consider with adding a lot of exterior installation is you start to have to be more considerate of the cladding that you're adding and the weight of that and how that then ties back into the structure. There's definitely ways to solve all of that. Whether that's cost effective, I think should be analyzed, with your build team to just make sure that, because the insulation you're going to need it regardless, and where it goes could have an impact on the overall cost for that final project delivery in terms of the cladding that you're adding. So I think that just making sure that your build team is thoughtfully analyzing it and not just taking what's in the plans and pricing it out. There's a lot of ways to slice it, and that's something that we're commonly doing in the design phase is looking at, what type of structural members are being presented and is there ways to do things with different types of materials to do it faster, easier, cheaper. And so making sure you have a team built around you to support that level of analysis, I think it would be helpful.
What did you use in the double wall?
We used the double stud is a thermally broken double stud cavity. I think it's 9.5 inches. That was blown in dense packed cellulose. And I think it was around a 4.2 per inch. And then for the service cavity, you didn't see any of the photos, but we do that in house and we fill that with rock wool.
Thank you.
Mm-hmm.
Oh, that's very cool. And it's rock wool batch that you used.
Correct.
Yeah.
Yep.
Very cool. All right. Up next is Richard Gardner. Richard, you had a bunch of questions. Maybe some of them were answered, maybe not, but go ahead and ask a couple.
Yeah, thank you. Richard Gardner from Austin, Texas. I have a FIA certified home in flight. And Matt, I was humbled to see your airtightness metric. Our first score was very similar, 0.1276, but that was with all the windows and doors sheathed over.
Okay.
So, yeah, very great score. So we talked about a little bit about the 3D modeling, the ERV duct design, and I guess you kind of answered, but just confirming that doesn't allow understanding the static pressure of the duct network, correct? That's just the visualization of the design.
Correct. That's exactly. And I think the particular project that wasn't the project I showed, that 3D model is actually for a different project that we use for our guide. It was really important for this particular client, like to have no soffits. So that really helped us to ensure that we could execute without having to plan in the field. Because the reality is it's really hard to do that in 2D. You can do your best, but there might be something that you miss, and doing it in 3D really eliminates all levels of uncertainty.
So how do you estimate the static pressure of the duct design, given the fan is so sensitive to the static pressure? And choosing
Gabrielle, I don't know if you're able to answer that question.
Yeah, so we help with designing systems for projects and give projects, there's guidelines. So first of all, it's a very low flow system. And then the Brink system is one of the things that makes it so high performance and robust is its ability to overcome a certain amount of static pressure. And so the fans themselves actually have vane anemometers to check the supply and exhaust flow, keeping those balanced at the unit itself. And therefore, if there's added static pressure, either because of long duct runs, because of, you adjusting the diffusers themselves, because of turns, or because of a dirty filter, the unit, it actually, the fans ramp up to overcome that. Of course, there's limitations, but using a home run system supplied by us, we know the type of ducts and eliminate all the variables. So what we the ducts are recommended to be kept below 60 feet. And so with the flow rates that we specify and keeping the lengths below that, we can confidently, know that the flows are going to be achieved with the static pressure there. As long as, there's no, of course, the install is so important, and there's no convoluted turns.
Yeah, I guess that's a big factor, is having the dedicated duct network for supplies and exhaust. It makes it a lot more predictable. I wasn't planning on doing that on the supply side. Yeah, I guess, since you're there, I guess the Brink 600 ERV flare, is that going to be HVI certified or PHI certified or any certifications?
The HRV for the 600 is currently PHI certified, and we're working to get all of our units HVI certified. So we hope to announce that.
The ERV for the 600?
Correct. Yeah, actually, all of the units from ERVs and HRVs.
Do you know the time frame? I mean, I'm pretty close to finalizing my decision.
Hoping by the end of the year. That's what we hope. Yeah.
And hate to consume so much. You mentioned 2 ERVs, Matt. Does that create balancing issues? And if so, how did you overcome those?
We haven't done that. It's just something I oftentimes consider, because some of the bigger homes we're building, you're right up to the maximum amount of CFMs that you can deliver. So we haven't modeled that, but it's something I know has come up on some of our bigger projects. We've ended up not doing it for cost reasons, but just something to consider. And I think it's more from my perspective, it's more about the implementation and install, because like Gabby mentioned, you can just get some really long duct runs, especially if your mechanical room's in the basement and you have 2 floors to go up above that. So just the food for thought was more why I brought that up.
We've
I'm
seen-
right on that borderline of
Yeah.
2
And
or
we've
1.
seen, we've seen projects that use more than one unit, and essentially you're just independently balancing each so that you either it's like one floor that one unit serves or one wing of the home. And so essentially when you're boosting one unit, it's still staying balanced. So each unit is individually balanced. So there is, we're making sure that there's exactly the amount of supply. Certain bedrooms are connected to one unit, certain bathrooms. So the balancing actually is not too tricky.
Thank you very much.
Yeah, Richard, and if you are right between 2 and Gabrielle and Matt, throw in your 2 cents too, I would go up for sure.
Me too. Yeah.
Yeah, because when you max out a unit, you lose that efficiency. So if the unit is rated at a 90% efficiency, if you're running it at 100%, you're not going to get that efficiency. So if you run it more at 70% or it's somewhere between 70 and 80, you might get that 90% efficiency. And you'll also not be stressing it out so much. So you'll probably get more longevity and life out of the system. Plus, you've got a little redundancy too if you have 2. So a little future proofing there.
Yeah, I was definitely targeting even running it, 0.6, kind of the rated capacity, to put it in that sweet spot.
Good idea. Yeah.
Yep, that's a good idea, and allow for some room for boost in case you have some high contaminant events or a party.
Yes.
So just want to say thank you for everyone staying past the hour, to our speakers staying past the hour, answering so many questions. As Kim mentioned in the chat, feel free to connect with folks if you have other questions. And if not, we are going to wrap up now and hope to see you at the Field Notes event on Wednesday and the Cascadia Component Spotlight event on Thursday. Thank you so much, everyone, for joining. Have a great rest of your day.
Thanks, everyone.
Thank you.
Thanks, Matt. Thanks, Gabrielle.
Yeah, thanks, everyone.